All right, so we're talking about arrays. This is bad programming right here. Saying, okay, I'm going to make an array that's 5 elements long, and so you just stick that 5 there. And then anytime you have a loop, you go ahead and put a 5 there. Why is that bad? Because what if later you came along and you changed it to 10? Every loop, you'd have to change that other 5 to a 10, right? You know, there may be 100 loops in your code that refer to that. There's no super 100% reliable way of getting the size of the array in this language, unlike Python or Java. The best thing to do is to declare something like this: # define array underscore size 10, and then you can just use that everywhere. Of course, you might give it a better name than array size if you have a whole bunch of arrays, right? Like that. And then your while loops can be based on, oh, come on that. Much better way of doing it so that you can pass that value around. Now, it's possible to calculate the size of the array as long as you are in the same function where the array was defined. You can do it like this. You can calculate the length of the array in case you need to pass that length to a function. And why would you want to do that? Well, because the function is not going to have any way at all of knowing the size of the array. Please tell me we have volume this time. All right, look at that little thing. We've got audio. I apologize to everybody who didn't get to hear the lecture. I feel real bad about that, but on the other hand, it's not going to tank somebody's grade because we're not having the exam. Not covered in the exam, so anyways. But I do want everybody to learn it. Some people said they were able to follow along anyways without the audio.
I was a little bit. There were some areas where I was like, oh, I wish I could hear what he was saying.
Right. What lecture are we on? All right. So, new project. C underscore lecture M. Grab the boilerplate. Come on. Come on. Oh, really? Okay, finally. All right. New source file. Lecture M.C. All right, now we're good to go. So if we were going to write some kind of function that needed an array, whether it was going to print all the values out or to sum them up, it needs to know the size. So we needed some function that would print an array of events like that, and so it's going to accept an array of whatever size, int ia for an array of events. We don't know how big it is, so we're not going to do that. We're not going to put a number between those things. And then here we might want a for loop, right? So for int I is going to be the index, is equal to 0. I is less than, well, I don't know. Maybe I can calculate the size of the array like the book is showing me. Int size equals size of parentheses ia in parentheses divided by size of parentheses int. That going to work for us? And then I could do I is equal to 0, I is less than size, I plus plus, and try to printf each element of the array? Let's give this a try. So %d \n, end quote, comma, and then the array is called IA, and each element would be called I, because that's the subscript, that's the index, and that's the array name, which we're passing in to fill the parameter variable. So down here, we actually need an array. Oh, I forgot my semicolon here. Never put a semicolon on the for loop, put it on the line underneath it. Okay, so I need an array to pass to it. So int nums subscript in subscript, and let's just put a couple of nums in it. 1 comma 2 comma whatever, doesn't matter. Okay. So inside main, I've declared an array, and now I'm going to pass it to that function. Print underscore array underscore ints, and pass in nums. Alright, this looks real good, and it's not even flagging anything as an error. Looks promising, but let's run it and see if it really does print out 124, 134, 2. Or whatever numbers you chose. Alright, it printed out a 1. That's all it did. It didn't print out the whole thing. And the reason for that is that the size of trick only works if it's in the same function in which the array is declared. I don't totally get why, but it doesn't. So instead, we need the size to be passed in as a parameter into our function. So I'm going to erase that line. I'm going to pass the size in like this. So I'm adding a new parameter variable, int size. And now I need to pass that value into my call. Notice that we've got a red underline here. We don't have enough values. We don't have enough arguments to fill in the parameter variable. So I need to pass in the size here. Now the cheap, bad way of doing it would be to type in 1, 2, 3, 4, 5, and so put a comma 5 there. That's real lame. A better way would be to either calculate the size the same way that we did in this method, excuse me, in that function up there. Int size equals size of nums into parentheses divided by size of parentheses int. What this does is it returns the total number of bytes that the array occupies, and since it's 5 bytes of ints and each, since it's 5 ints and each int is 4 bytes, 5 times 4 is 20. So size of nums is going to be 20. And then the size of an int is 4, so it's going to be 20 divided by 4 is 5, which happens to be the size of the array. That's perfect. We need to pass that in. In this language, in C and C++, just get real used to, if you're going to write functions that work with arrays, always passing the size in. Now it should work. Now it should print out all 5 numbers. And there we go. There's our 5 numbers. Now we're feeling right about the universe. The other thing we could have done is to declare the size of the variable, right? Define, we were calling our array nums, so nums size 5, so # define nums size 5, and we could specify that as the size of our array, like that. Wait, I left an S off. Nums size, and then I could pass that in, like that. Both of those methods work. Kind of up to you which you like better. You like calculating the size of the array, or do you like specifying it beforehand like that? It's up to you. I think I'll add copy and paste that line and say or, right? Or, because they're both going to work, right? But if I'm going to do that, I'm going to move this line down underneath the comment. Like that. If this is an array of doubles, we just have to change the size of right here to not be int, but double, and so on. If it's an array of characters, you put size of char. All this. All right. So initializing a one-dimensional array. To initialize a one-dimensional array, you can put a loop. That doesn't look like an initialization. That's talking about how to pass it to a function, which we've already talked about. The header's wrong. PowerPoint's here, needs some editing. Traversing an array in a function. Well, we just demonstrated that, except this is using a while loop. If you're using arrays, you may as well use for loops. For loops, just the syntax is better because you specify the starting point, you specify the condition, and you specify the update all in one line. So strings. Strings are character arrays. If we have this string, character name is equal to Fred, what it really means is that it's an array of characters where the first value is an F, the second value is an R, the third value is a D, the fourth value is a D, and the last value is a 0, indicating the end of the string. We can prove that to ourselves. Let's declare char, food, like that, equals, quote, pizza, end quote. But I would like a size to go by, just like we did up here. So I am going to go ahead and declare a constant, which, well, I mean a macro that declares the size. So # define food underscore size. Maybe we want to make it large so that if we later went back and called it, caviar from Bulgaria, some long words, it would work. Maybe that's a bit too long. Maybe we just make it 20. I just need it to be at least this long plus 1 for the 0 at the end of it. That word is 5 long, so we could get away with just making it 6. But asparagus is longer, so that wouldn't be a good idea. But for now, we'll just leave it 6. Food underscore size. Now let's make a loop that prints it out. For parentheses int I equals 0. I is less than food underscore size, semicolon, I plus plus. Printf. Now, instead of printing the letters out, I want to print their integer values so that we can see the ASCII values. We've talked about ASCII where an A is a 65 and a B is a 66 and so on, like we could look at ASCIItable.com to see. So I'm just going to print it out with %d \n. You know what, I guess I could print out both the %d and the character itself. Why not? So %c space %d \n, and now I need 2 parameters, 2 arguments to fill in those 2 parameters. So I need food subscript I, and then I need the integer version. I want to convert it to an integer, so parentheses int end parentheses food subscript I, in subscript in parentheses. And here we see it. Let me increase the size to make it a little bit more obvious. Right, here's our string. character array. P-I-Z-Z-A and followed by this empty character 0. It's called a null, so it's a null terminated character array. So if we're going to write something that processes this string and needs to stop when the string stops, we could be checking for that 0. Let's increase food size. We do want to handle caviar from Bulgaria. I'm going to make the array 40. All right, I'll be right over. Okay, and so we see with it increased to 40, right, the first 5 characters in the array are dedicated to our word. The 6th character is a null, and we don't really care about the rest of them, but they all happen to be nulls as well. If we didn't want to do it this way, we could do the same thing that we did up here, where we recalculate the size, and we pass that in to our for statement. Would not be a bad idea at all. Or you can write the for statement itself to take into account that we're looking for a 0. And I'll show you what I mean in just a minute. So what we're going to show here is a way of handling it without using the size at all. But it only works if we're using strings, only using character arrays. Right? There's no 0 at the end of this, so this method would not work for the nums. But it will for our character array because we know that it's P-I-Z-Z-A followed by a null. So we could print it out like this. I'm going to comment this one out. The above code works fine, but we can make it a bit more general if we just check for the 0 at the end. Something more like this. For int I equals 0, semicolon. And when are we done? When food underscore I equals 0. So we want to keep going while food, not underscore, what did I say? Food subscript I in subscript is not equal to 0. Because as soon as it is equal to 0, it means that we've hit the end. Semicolon, I++. And now let's print that. Heck, we could just copy this line of code and paste it rather than type it in again. That printf statement. Now when we run it, we're not going to see any of those zeros at all. P-I-Z-Z-A. There's still a 0 at the end of the array, but we stopped when we found it because that was no longer true. So it kicked it out of the loop. Now some programmers like to get even more clever, and that's what this PowerPoint is showing. A string is a character array. A character array is a string. You can use pointers. Everywhere we have declared a character array, whoopsie, 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 like this, if we were going to pass it to something, we wouldn't have to declare it like this. We could declare it like this, just like we had been doing, like we did with the int array. But this and this are actually identical for reasons I'm not going to really explain, except that when we pass this array into a function, what it's really doing is it's passing the address. And we know now that this is a pointer, and so it would pick up that address. And if we wanted to be all special about it, we could use this in order to print it out. Now that's a little bit too clever by half. There's nothing wrong with it. An experienced C programmer would understand what's going on. I don't care if we really understand it or not. What it's doing is it's saying while this is pointing to something that's not null, we could rewrite it like this. While whatever we're pointing at is not 0, print it out, and then add one to our pointer, add one to our address, so we keep going through the array. It's fine, it works. Now if you do something like this while something is not equal to 0, you can leave that part off, because this means the same thing while that is not equal to 0. So this is really kind of a short form for doing what we just did. We could copy this code and paste it into here and get it to work. But conceptually, I don't mind if we leave it like this. I think this is just fine. We could probably get away with removing that INT. I wonder if we can. I'm going to take that out and see if it works just as good. Yeah, okay, great. Looks better. This just says we're printing it out as a character, A, B, C, D, E, and this just says that we're printing it out as its underlying number, its ASCII value, 65, 66, 67, and so on. So you will probably see people, if you go on to do C programming, do something like this. Let's do like a pointer to my food array. But to indicate that it's a pointer, you need to do that. Equals food. What this is doing is it's pointing to the same address. It is now the same array. If we change the first letter of food and then we try to print it out using pfood, something like that, it'll be changed for both of them. Right now it's pizza with an uppercase P. We're going to change the first element of that array to a lowercase p. So food subscript 0 in subscript equals single quote, because it's a character. Can't use double quotes if it's a character. Lowercase p. So apostrophe, lowercase p, end apostrophe, semicolon. And now if we print out pfood, like it was a string, if we print it, if we print f it, the %s, printf, parentheses, quote, pfood, %s, \n, end quote, comma, pfood. Now when we run it, we're going to see that it changed it to a lowercase p. Even though it doesn't look like we did anything with pfood, it looks like we only changed food, this is a pointer to that. So we have two references now, two pointers to the same memory, that was containing these letters. So we can change it either way. It's like two street signs pointing to the same house.
So that P could be any one of those letters. Like if you could change that to Z.
Well, we could put it as a question mark, and then when we ran it, it's going to say question mark IZZA. What if we wanted to change that A? Well, this is character 0, because with arrays, we start counting at 0. 0, 1, 2, 3, 4. So if we wanted to change that A to something else, we change this 0 to a 4. And now it's going to say PIZZ with a question mark at the end. That makes sense? Yeah, good. So how do you access the elements of an array? We do it by its subscript. And we've talked about that already. So the 11.1 is index element number 0, subscript 0, index 0. This is element 1, and this is element 2. So when we print it out, it's going to, the first one's going to print out as 11.1 because that's element 0. And the second print statement is going to print out element 2, which is that one, so it's going to print 33.33. So an uninitialized array is not a good thing to use. Like if we declare an array kind of like our food array, but we don't put any data in it, it could be bad. Let's do that. Let's make an array, maybe call it dessert, I don't know. care, dessert, subscript, food underscore size, in subscript, semicolon, and let's print it out. For, same kind of thing, int I equals 0, semicolon. Now we're going to make sure that the character we're looking at is not a 0, because that marks the end of the array. So dessert subscript 0, excuse me, subscript I, not equal to 0, semicolon, I plus plus, and we don't need those braces, we didn't use them up higher, why use them now? Printf, just like this statement here, %c space %d, %c space %d, \n, end quote, comma, and our array is called dessert, so instead of food I is going to be dessert I, comma, dessert I, in parentheses, semicolon. We're not going to like the way it looks. Look at all this garbage. That's because it's what's known as uninitialized memory. It's filled with 52s and stuff. Maybe there's a reason for those 52s, negative 52s, whatever they are. If we compiled it for what's known as release mode, which removes all the debug code that Visual Studio is adding it, if I come up here to debug and I click it for release, if you ever gave your .exe file to someone else, you would want to compile it in release mode. Now here we go, we run it. Alright, well, still doesn't look good. It doesn't have a whole bunch of 55s. We don't know where those numbers came from. They just happen to be whatever was in those bytes. It's like if you move into someone else's house but they haven't cleaned it out. Now, who knows what's under the sofa then. So let's initialize it. Let's just give ourselves something like this. If we put that there, then we're no longer using uninitialized memory. What this does is it copies a 0 into the first place, into the first byte. That's enough, because then it'll ignore all the rest. But it'll copy a 0 into the first place, and so when it prints it out, it's really not going to print anything, but that's better than anything else. It's better than the behavior we were seeing. So if it's a string, you can get the length of it because you're guaranteed that there's a 0 at the end of it. There's a function that'll get us the length of it called strlen. So if we wanted to, we could get the size of the food array and print it out. I don't know what I'm going to call it, so I'm just going to call it x. X is equal to strlen, parentheses, food, in parentheses. It's going to equal 5 because pizza is 5 long. I guess we'll make sure of that. Why don't we printf that out? Printf strlen food equals space end quote. Wait, forgot my \n and my %d. %d \n end quote comma x in parentheses semicolon. I just want to make sure it's 5. And there we go. Yes, since it's now PIZZ question mark, but whatever, right? It's still 5 characters long. So we could write our for loop rather than doing something like this. We could just make sure that we haven't passed this into the string. So for int I equals 0, I less than strlen parentheses and the name of the array we're printing. Let's go back to printing food because dessert is empty. That's a sad state of affairs. Food, end parentheses, semicolon, I plus plus, and we can just printf it out. Printf, let's do it slightly differently just for fun. %C followed by a space with no \n. We're just being a little bit different. And then food subscript I. Now this is going to print everything on the same line. And we haven't hit the /n. We haven't hit the enter key effectively. So the next printf is just going to be printf parentheses quote \n to get to the next line. Quote \n end quote in parentheses semicolon. All right. And now I printed out our string. Now I did put spaces between it because I had a space here, right? If I took that space out, it would take the spaces out from our output. So you just kind of pick how you want to do it. You want to use a macro like this to indicate when to stop. You'll want to check to see if your current character is equal to 0. If you feel like using strlen, it all works. Along with strlen, there's another function called stringcat, strcat, which appends, concatenates something to something else. So let's stick something in the desert array. strcat, parentheses, dessert, comma, quote, ice cream, end quote, in parentheses, semicolon. This is an unsafe operation because if dessert is not big enough to hold this string, it'll write past the end of it and go into some memory that it's not supposed to. So we should use a safe version of stringcat. Well, at least it didn't blow up, but let's print it out to make sure that dessert now equals that. Printf, parentheses, quote, today's dessert is %s \n, end quote, comma, dessert, parentheses, semicolon. All right. Did I do something wrong? Oh, what did I do wrong here? Something wrong with my % sign here.
There's no %.
Yeah, there's no %s there. It's a string, so I need to print it out with a %s.
Why didn't you change mine to that?
And there we go. Today's dessert is ice cream. There we go. So we copied, we so-called concatenated this value. Now if we just really wanted to copy it rather than append it, we could use strcpy. That means copy. It means start from the beginning. strcat means append it to what's already in there. So like we could do this, stringcat dessert, comma, quote, space, from Brahms, end quote, in parentheses, semicolon. And just copy this line and paste it again rather than type it in again, that printf. And there we go. Right, the first time it copied it in there, so it said today's dessert is ice cream. If you do strcpy, it removes whatever's previously in there. It starts at the beginning. If you do strcat, it starts at whatever's already in there at the end of it. So today's dessert is ice cream from Brahms. Let's make a comment. A couple of comments. strlen, parentheses s, returns the length of string s up to the null at the end. I think I'm going to remove the word string there. Returns the length of s up to the null at the end. Just keeps counting until it finds a 0. strcopy s, comma, t, copies the contents of the T array into S up to the null at the end of T. And then we add one more string cat. String cat S comma T copies the contents of the T array, placing it at the end of the S array where the null is. In other words, it appends. In other words, it appends T to S. Sorry for writing it in a little bit too computerized, but trying to get it exactly defined. You can just think, okay, it copies it and it concatenates it and it appends it, and that's enough. But just know that behind the scenes what it's doing for is all these functions are looking for that 0 at the end of the data, and that's how it really knows when to stop. Now there should be safe versions of these. Let's see if the PowerPoint talks about them. We're on slide 25. Safe. Nope. Well, we'll go and find one then. Safe version of strcpy. strcopy can write past the end of the array. If this second array, if the desert array, was only declared to be, where did we define it? Right there. If it was only like 4 bytes wide, there's no way that ice cream from Brahms would fit in there. And so bad things might happen. Yeah, it blew up. Buffer, well, it didn't even compile actually. What do you know? I'm surprised it caught that. Quite often the compiler will not catch that kind of error, and you won't see it until runtime. And you may not even see any errors at all when you run it, and somebody else might see it when they run it. Kind of the worst error. One that happens sometimes and not others. But we got to find a safe version of it. That's not what I wanted. String copy S. But that may be a C++ function. Let's take a look and see if we can get it, find it to work. Well, let's just use strncopy. strncopy means copy up to a certain number of characters. So like if we made a string that was 10 characters long, like this, char, I'm just going to call it snew, because it's a new string, and it's 10 characters long. I'm going to go ahead and initialize it like that, so it's a proper string, and I'm going to copy a word into it, strcpy, into snew, comma, something that's more than 10 characters long, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. But I can specify the length of it if instead I use strncopy. So how many characters can I copy? Well, this is 10 long, but I need to leave space for the 0 at the end, so I can only copy 9 characters. So I'm going to put 9 there. And then when I print that string out, we're going to see that it only copied the first 9 characters, which is good. That's all we want to do. Again, it would have been a good idea to declare some kind of variable that indicated the length of that string, or some kind of macro. # define s underscore size 10. Don't put the equal sign. And I might define this as being s underscore size plus 1. Why plus 1? To give myself space for that 0 at the end, so that when I call str in copy, I can just print it out to s size rather than subtract 1 from the size, which is what we were doing previously before. So, not a bad idea to define your size as a macro and then add 1 to it when allocating the character array. All of this business about terminating the array with a null applies to character arrays, strings only. Don't think of these things with arrays of ints, doubles, whatever. Only characters. Now, yeah, you could make your other arrays into the 0 and try to pull the same kind of things, but you're not going to have cute functions like str in copy. So what does str in copy do? We've already talked about a couple of versions. We talked about str copy and str cat. Let's add one more to our comments up here. Str in copy, except remove the O. We wouldn't want to actually have any vowels in our words, would we? S comma T comma N copies the first N characters from the T array into the S array. Is it working? Are there any syntax errors I need to come look at? Okay, cool. Not yet. You've got to try harder then. Alrighty. I'm going to take a break from doing this. Veer off track slightly yet. I don't have done any. So to get file I/O to work, we need to include the stdio header file, which I believe we have, stdio. So we're going to come down here and we're going to create what's known as a file handle. A file handle lets us save data to a file. It lets us print data to a file. Except instead of printf, we're going to be using fprintf. So file, and you'd have to ask the guys back in 1970 why they made it uppercase. Star P file, pointer to a file. I like making every pointer begin with the letter P, just because the examples show it as being FPTR, standing for file pointer. You could just call it file. We're not going to have to use any fancy syntax about putting an ampersand or any asterisks in it, so maybe this one time we can get away without using the P in it. So file asterisk space file, and now we're going to open it. So file equals fopen parentheses, and we need a file name, food.txt, end quote, comma. And how are we opening it? If we put a quote R quote here, it would open it for reading. But like in Python, we're going to put quote W quote in there to indicate that we're writing to it, and it needs to be double quotes. Now we have a file we can write to, but we need to make sure that didn't fail. Why could it fail? What if we try to save to Z and I don't have a Z drive? Or what if the drive is full, there's, or it's write protected or whatever. There's all sorts of things that can go wrong. So we need to make sure that there's nothing wrong with it. If parentheses file equals caps, N-U-L-L, which is just a fancy word for 0. We could replace that with 0, but I'm going to leave it null. That's an error. We're going to print an error. Printf, parentheses, quote, could not open file, \n, end quote, in parentheses, semicolon. Else, we have a file. We may as well save our food and our dessert to it. Else, open curly brace, printf, parentheses, quote, saving data to file. That's just to let ourselves know what we're doing. \n, end quote, semicolon. And now we're going to print some data to the file. Not using printf, but fprintf. Fprintf, parentheses. Our file pointer is called file, lowercase, comma. And then our string, well, the same. We're going to do it the same way we've been doing it before. We can make it fancy and say meal equals %s \n, end quote, comma, food, end parentheses, semicolon. And we're going to do the same thing for the dessert. Fprintf, parentheses, file, comma, quote, dessert equals %s, period, yum, exclamation point, \n, end quote, comma, dessert, in parentheses, semicolon. And now we're done with the file. We need to close it. You always want to close your file as soon as possible because the operating system will keep it open, and if you try to copy it to another directory or something like that, or you try to save something else to it, it'll say you can't. So we need to close it with fclose, just like we used fopen to open it, fclose to close it. Fclose parentheses file. And why don't we print that we close the file now? Printf, parentheses, quote, file closed, \n, end quote, in parentheses. And as a matter of fact, when we open the file, why don't we put a comment there, a print statement there as well, saying what we did. So printf, parentheses, quote, opening file, \n, end quote, in parentheses, semicolon. Now, it's real nice to let the user know the file name. And actually, we should have stored the file name in a variable. So why don't we do that? Why don't we store that file name in a variable? It's just a string, though. So, char fname for file name, subscript in subscript equals, quote, food.txt, end quote, semicolon. And now I'm going to change this so that it uses that file name rather than that hard-coded string. We could ask the user for the file name. So fopen, parentheses, fname, comma, quote. And here we're going to tell the user what file we're opening. So we just need to print it like any other string with a %s. So opening file space %s, %s \n, end quote. And here we need to actually pass that variable in, fname, end parentheses, semicolon. So we changed this line. I'm just putting that there to indicate that we changed that line. We changed that line, and this line here was new, right? So these are the 3 changes we've made. These don't add these comments. They're just for the people following along in the video. All right, so those are the 3 things we did. We added those. Let's run it and see if we actually get our data saved in our file. We're going to go looking for a file called food.txt. Hopefully it's there after we run it. Okay. Okay, so opening file, food.txt, saving the data to the file, and then file closed. Let's go find that file. If you're using Windows, it's easy to find a file. I mean, if you're using Visual Studio, you just come up to the Solution and Solution Explorer, right-click, and do Open Folder in File Explorer, and we should be able to find that TXT file. Is it going to be in the release directory? I don't recall. Nope,
Lecture.
it's in the lecture. Yeah, there we go. And so if we double-click it, ta-da, there's our file. Still got a question mark. But there it is. We have created a file. Now we could open the file using fopen with an R, and we could use scanf to pull data from it just like we do from the keyboard, right? So if it was a number, scanf %D, right, to read that number in. Except it would be fscanf because we're reading from a file. Yeah. All right, let's stop here. No homework. Please come in on Monday for the final. If you're not here, you know, there is no final, but you don't get the 100% on the final if you don't attend the lecture or make other arrangements with me.